Welcome viewers. In this video we'll see the 3-bit synchronous up-down counter. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic 3-bit synchronous up-down counter. So counter is a digital device made up of flip-flop. So it will store 1-bit data. It is used for counting purpose, either from 0 to n or n to 0. 0 to n means up counter, n to 0 means down counter. So it is made up of flip-flop. All the flip-flop receive the same clock signal. Simultaneously, clock signal is given to all the flip-flop, mean it is synchronous counter. One more type, asynchronous counter. First flip-flop will receive the clock pulse. Output of first flip-flop is given as clock pulse to the second flip-flop. So the operation is not synchronized. That is called asynchronous counter. Here the 3-bit counter we are going to discuss. So 3-bit, 2 to the power 3, 8 combinations will be available. 0, 0, 0 to 1, 1, 1 for up counting. 1, 1, 1 to 0, 0, 0 for down counting. So both the operation up and down can be done in the single circuit. Now we'll see the detail. To form a parallel up-down counter, the control input up bar down, the down complement input down is used to control whether the normal flip-flop output or inverted flip-flop output are fed to J and K inputs of the following flip-flop. Right, so we are using up and down, complement of down, down dash. We are using this control input. This input will decide two types. One is normal flip-flop output or inverted flip-flop output. If we give the normal flip-flop output to the next stage of flip-flop, mean we'll get up operation. If the inverted flip-flop output is fed to the next flip-flop, mean we'll get down operation. So that control is done by this control input, up down dash. This will decide whether we are going to feed normal flip-flop output or inverted flip-flop output. Now we'll see the logic diagram. So because of 3-bit counter, we are having 3 JK flip-flops are available, A, B, C. So A is LSB, C is the MSB. The output is QA, QB and QC. For both up counter as well as down counter, output is taken from QA, QB and QC. Right. So this is the control signal, up down. Here the control signal M is directly connected to the, we have one AND gate is available, 4 AND gates available, 1, 2, 3, 4. The signal is directly connected to AND gate 1 and 2. The inverted signal, we are using NOT gate. If M is 0 mean here 1 is connected to AND gate 3 and 4. AND gate 1 and 2 is connected with QA and QB, normal output of the flip-flop. AND gate 3 and 4 is connected with complement of the inverted flip-flop output, QA bar and QB bar. Right. So if the AND gate 1 and 2 is enabled, means QA will be applied to the next stage of flip-flop. If 3 and 4 is activated, means QA bar will be applied to the next stage of flip-flop. So 1 and 2 activated, mean QA applied up operation. 3 and 4 is activated, mean QA bar applied down operation. Right. Now we'll see this. First flip-flop J and K receive the high signal. Always the input is high for the first flip-flop. In JK flip-flop, if both the inputs are high, the output is toggle. That is the nature of the JK flip-flop. Both the inputs are 0 means no change. Both the inputs are 1 means it will toggle. For every clock pulse, it will toggle. And also here you are using the negative edge clock pulse. Whenever the negative edge crosses, the state of the flip-flop will change. Right. So first flip-flop, J and K input always high. So for every negative edge of the clock pulse, the output is toggle, 0 to 1, 1 to 0. Right. What about the second flip-flop? Second flip-flop is connected through this logic, 2 AND gate and 1 OR gate. We already discussed, if 1 and 2 is activated, mean normal output. 3 activated means complemented output. That is decided by this. For example, if M equal to 1, then 1 is applied to this AND gate. Inverted output 0 is applied to this AND gate 3. So 1 is activated, 3 is deactivated. So 1 is activated means QA will be applied. QA. So it will perform the up counting operation. Right. Here also same. If J and K receive the high output 1, both are 1 from this. From this both are 1 means QB will toggle. Suppose both are 0 means QB will be no change. Right. So here permanently 1 is connected. So every clock pulse it will toggle. But the second flip-flop QA is connected through the AND gate. So QA means if QA is 0, no change. If QA is 1, the output will toggle. QB will toggle. Similarly, if the control input is 0, then 0 is applied to the AND gate 1. So it is deactivated. This 0 is inverted, become 1. 1 is applied to the AND gate 3. So AND gate 3 is activated. Now connected with QA bar. Right? So if the control input is 0, 3 is activated, QA will be applied to the second stage of flip-flop. QA bar is applied so that it will perform the down operation. This QA bar is 0 means no change in the output, no change in the state of the flip-flop. If QA bar is 1, then the output QA will be toggle. Right? So this is the connection diagram. For first flip-flop always 1 is connected. Second flip-flop either QA or QB connected based on the signal. 1 means QA connected. 0 means QB will be connected. So that it will perform upper operation or down operation. If both are 0, no change in the state. Both are 1, there is a toggle. Right. So the output of this flip-flop depends upon the value of QA or QB. Similarly here also. Same thing. Here 2 and 4. This 2 and 4 is connected. Same thing. If QB is connected, up operation. QB bar is connected means down operation. Both are 0 means no change in the stage of the status of the flip-flop. If both is 1 mean there is a change in the status of the flip-flop QC. Right. So based on that we will see the timing diagram. First we will see the up counting operation. So this is the clock pulse. There are 8 clock pulse applied. So this is the positive edge. Changing from low to high is the positive edge. But we connected with the inverter. Changing from high to low is the negative edge. So during every negative edge, the status of the flip-flop will changes. Right. So this is the positive edge changing from low to high. High to low is the negative edge. So during every negative edge, the status of the first flip-flop will change. Because first flip-flop always connected with the logic 1 for both J and K. Right. So this is the QA output. First flip-flop output. See this is the control signal M. Now M is 1. So AND gate 1 and 2 is activated, is performing up operation. See this during this negative edge, initially all are 0. During the first negative edge, 0 changes to 1 because always J and K input is 1 for the first flip-flop. So every clock pulse it will toggle. So this will be maintained until next negative edge. During next negative edge, 1 is changed to 0. During the third negative edge, 0 changed to 1. During fourth negative edge, 1 changed to 0. Like that it will keep on toggle. So every negative edge, the status of the flip-flop changes from 0 to 1, 1 to 0. Because J and K receive the high input. So there is toggle. Then the second flip-flop output. Second flip-flop output is based on the QA value. QA is connected as a input to the second flip-flop. So whenever QA going a negative edge, whenever the value is 1, then when the QA value is 1, toggle. If the QA value is 0, no change. See here QA value is 0, no change. 0 is maintained as it is. Now QA is 1, so it will toggle from 0 to 1. Now QA is 0, no change, 1 is maintained as it is. Now 1, so toggle from 1 to 0. 0, no change, 0 is maintained as it is. 1, so again it is toggle from 0 to 1. 0, no change, 1 changed, right? So whenever QA is 1, toggle will occur. If the QA is 0, same status will be maintained, right? So because first flip-flop output QA is connected as a input to the second flip-flop. Now the third flip-flop QC. QC is third flip-flop is the input. QB is connected as a input to the third flip-flop. So based on the QB value, the output of the third flip-flop will changes. See here 0, no change. Here also 0, no change. This is rising edge. So here 1. So due to the 1, now changes 0 changed to 1. Now this again it is 0. Here it is 1. This is negative edge. When the negative edge is crossing, at the time only the status will change. Here also this is a negative. This is negative edge, right? So whenever there is a, because we connected the negative edge of the clock pulse. So during this time it will not change. During this time it will not change. During here only it will change, right? So here 0, so no change. At this point it is a positive edge, so during negative edge it changes from 0 to 1. Again if the 1 is occurs, 1 is changed to 0, right? So now we see the output. This is LSB and MSB 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, right? We got the up counting, right? So here we are using negative edge of clock pulse. The M signal is 1, so up operation is performed. First flip-flop is connected with 1, logic 1 for both J and K. So every clock pulse, negative edge of the clock pulse output toggles. Second flip-flop, QA is the input. Whenever 1, the status changes. Whenever 0, no change. Third flip-flop, QB is connected as a input. So 0 means no change. 1 means changes. Changes from 0 to 1. Same thing. 0 means no change, right? So now we discuss the up counting operation. Now we'll see the down counting. We'll see the timing diagram for down counting. So this is for down counting operation. The M is 0. So that will perform the down counting. There are 8 clock pulses available. So during every negative edge, the status will change. So this is QA. Initially 0. Due to this negative edge during the clock pulse, 0 changed to 1. Similarly negative edge, second negative edge, 1 changed to 0. 0, 0, 1, like that it will toggle. Because first flip-flop connected with logic high for both J and K. So every negative edge of the clock pulse, the output is toggles. But for the down operation, we applied QA bar to the next second flip-flop. So this is QA means this is Q bar. It changed. 0 is converted into 1. 1 is changed to 0. Right? This is 1. This is 0. 1, 0. Now this inverted output is applied to the second flip-flop. So whenever there is a negative edge, whenever there is a changing from 0 to 1, it will the status will changes. So here is 1. So that the flip-flop toggle from 0 to 1. Here 0, so it is maintained as it is. Here 1, so toggle from 1 to 0. Here 0, no change. Again here 1, so changing from 0 to 1. Here 0, no change. Here 1, again toggle from 0, 1 to 0, right? Whenever there is a changing from 0, whenever 1 toggles, whenever 0, no change, whenever 1 toggles. So that we got this output. Now this is the QB. QB bar is applied to the third flip-flop. So it is inverted, QB bar. Now it is inverted. 0 means 1, 1 means 0. The signal is inverted. This signal is applied to the third flip-flop. Now this is 1 here. So due to 1, the flip-flop toggles from 0 to 1. So here fully it is 0, so no change. Here 1. So due to 1, again the flip-flop toggle from 1 to 0. Here 0, no change. Here 1, so the next stage will toggle. So during this negative edge, during this position 1 to 0 toggles. During this position 1 to 0 again toggles. Right? So we got this output. Now we'll see the value. We already discussed QC, QB, QA is the output for both up counting and down counting. See this value, it is initially it all are 0. Then it is 1 1 1, 1 1 0, 1 0 1, 1 0 0, 0 1 1, 0 1 0, 0 0 1, then 0 0 0. Right, we got the 8 combination of output for 3 digit in a reverse order. That is, so that it is coming under down counting. See, is available 0 0 0, 1 1 1, 1 1 0, 1 0 1, 1 1 0, 0 1 1, 0 1 0, 0 0 1, again it is 0 0. Right? So we are getting the 8 different output in a down operation. That is from 1 1 to 0 0. Right? So this is the output is QC, QB, QA. This is LSB. QA is LSB, QC is MSB. For both up operation and down operation, there is no change in the output terminal. Output terminal is these three for both operation. So in this video we discuss 3-bit synchronous up-down counter. For up operation we are connecting Q to the next state of flip-flop. For down operation we are connecting Q bar as a input to the next stage of flip-flop. Then we have control signal M. If M equal to 1, it will perform up operation. If M equal to 0, it will perform down operation. Then we discuss the timing diagram for both up counting as well as down counting. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.